Okay, hello everybody, my name is Giuseppe and Angela, I work for KDAB, and this will be a very fast and short talk about doing categorized logging in QML. This will be a slight change of the rules, so if you vote for this talk and this talk only, you can win a cake. And you know what to do. Okay, very briefly, let's discuss a little bit of how do we do logging in a Qt application, using, of course, Qt facilities, so I'm not talking about log4cpp or stuff like that. So Qt historically provide only this family of functions over there, so QDebug, QDebug, QWarning, QCritical, QFatal. And that has a very nice and easy way to just log any kind of information. Those functions take strings, objects, you can just like dump on the console everything you like, and also they support this nice printf style for doing stuff. The problem with this kind of API was like, where did the messages come from my source code? I just see a string printed on my terminal, and I have no idea what's logging that. Do I really need to put qfunc_info every single time I want to know, okay, this message there has been logged for that function, and so that's spamming my log messages with the function name every single time? Can I categorize the messages in more like semantic areas, in something that makes sense for my application? So I have the module A, which just logs everything, say this is module A log, and module B that says the same thing on the other side. Can I enable and disable them at runtime without doing any crazy stuff at compile time to enable disable them? The answer is yes, you can, thanks to the guy sitting over there. It's Kai from Digia. Qt 5.2 introduced a new nice logging framework, so you can just create and define custom logging categories like that. That's the declaration of a category, and that's the definition of a category. Of course, that appears in H file, that appears in C++ file. And so then we got nice functions called QCDebug, QCCritical, QCWarning, QCFatal, and we log those messages exactly to that category. And the fancy part about that is that we can then decide at runtime to, okay, please show me all the debug log for that category and nothing at all for that other category over there, which made just sense, right? And yeah, so at runtime we can just define a bunch of logging rules in a file, an environment variable, and we have nice APIs for filtering messages and also for outputting them. Now a message is rich and also contains various information, for instance, the line of source code that it outputted that message. So if you'd like to know more about all this stuff, please go to Kai Talks tomorrow, because this is the C++ API. What about QML? Right, this is about QML. Well, we can log some information from QML. We have the console object, and we can write console log that, console warn that, and we also get nice source code information thanks to the fact that we're using v4, so we get the line and the file number, the file name and the line number of the specific piece of specific code that emit that output. And so I can trust me that if I run that, what I get is that as output. So I get the file, the line number, I get the category printed, and the message. And the D at the beginning is just like saying it's a debug message. What's the problem in this scenario is that the category is QML, nothing more, okay? All logging that we do from QML sources get logged into the QML category, no matter what. Even if it's coming from other pieces of code, or you have a very complex application where the 10 different subsystems and complex state machine, everything gets logged in there. You get no control about all the various parts. So of course we didn't like that, and I tried to find some interesting ways to work around that problem. So take one. Okay, this is the easy way. How do we go about that? We can move logging into C++ by doing a nice trick. We just create a QObject subclass, which has an invocable method, such as slot, or a method marked as QInvocable. And then, in those methods, we just log those messages into a category, and we expose those objects to QML, right? It's that simple. So basically, from QML, we don't write console.log. We write my own console, my own logger.log. And try to show you right now if this works. Oh dear, I hope it fits. So basically we create a nice QObject subclass. It's called logger. It gets the category you want to log in, an apparent, whatever, and there's a nice log method over there, here, which just dumps the string inside using QCDebug inside the category. We pass it at construction time. So in main, I just create a logger object passing a category in, and I expose that object to QML that way using the set context property method. Fairly easy. Let's try running this thing and see if it works. But you can already spot what's the problem with this thing. And if you can read the problem, if you can read that, yeah, the problem is that we got everything fine, but the source code information was lost. That's because actually logging is happening here inside my main file. So I got the information that I'm logging from main CPP line 20, which is exactly here. I totally lost the information from the QML file. If I take a look at the QML, I'm simply doing logger, log, SA, hello from logger. So that's bad. We don't want that. Let's move on. Yeah, the category is correct, but the source location message is lost. And we got that wrong line number there. So let's build on that. That's a good idea, but we need to make some adjustments. Let's actually dig into v4. How is the console object actually implemented? Well, that's the file you want to be looking at. That's the file that provides all the built-in JS functions inside the QML engine. And so basically, yeah, we can just get inspired from the code, and do the same, right? So let's do a bit of injection in v4, and that's actually how the thing is implemented. So we subclass v4 object, that's an object of the engine, and we need to do a whole bunch of boilerplate code in order to just expose some stuff to the JavaScript engine using v4 APIs, which are just horrible at this level. So we just create this object, and we define some JS properties on that, so log, debug, warn, stuff like that. And then inside our logging method, we need to do basically all the JS boilerplate by hand, by extracting the stack frame and the source code information, and then mangling by hand all the call parameters of the log method. And then in the end, we again use the logger debug, logger working for C++, but this time we're building the logger object using the actual source file information from QML, so this time it should be correct, I hope. Let's try running. Yeah, it runs, and you can see now everything is fine. Everything is coming from QML. Okay? Wow, good. We can build on this. Yeah, you can upload if you want. we can build this. The problem is, okay, as you can see, that amount of private APIs just scary. Too many APIs used, and in 5 days, Tronicle is going to redesign the engine. Everything's going to break. So yeah, it's not very solid. Let's take something better than that. But basically, seeing a couple lines in the previous example, which allows us to get the engine from a QML engine. So what's that method? Well, basically, at any time we get a callback from QML into C++ code, the QML engine is stopped there. So we can ask the engine the information about the current stack frame. So basically, what's the line number and file name. And that's it. Basically, we're gluing back the previous two solutions by getting exposing a Q invocable on a normal Q object. But in that Q invocable, we actually get information from the engine about the source code information. So again, let's see that in action. Here we go. Oh, sorry, I can read that. This is again a Q object, playing like that. It has a log method, which is invocable from QML. And in here, we just get the current stack frame using just that tiny bit of private API. It's just like that. And then we log. So we build a logger using the frame source, line, function name, and we log to that category. Just as simple. I can run it, and yeah, all the categories are correct. So this is my custom category. Yeah, I'm done. Good. And that's my custom QML file. Yeah, just like that. Okay, demo. Just some final touches if we need. Okay, we might want to support to do just like what log does, supporting multiple arguments. And yeah, we still need to set all those logging objects as properties of the root QML context. We cannot expose them as like global JS functions, and that's a reason. It's just historic. Basically, the global JS function in QML is frozen, so we can't modify it directly. We still need to go through set context property. Well, you cannot add properties to global JS object, but you can modify the global JS object, right? So we can just also override console's category by just like overriding its own properties. Let's have a look at that. So this should be it. These are very fancy stuff. So I'm declaring two categories here, one from my log and one from the console log. And in here, well, some nice C++11 stuff to do all the mangling I need. But the neat part about this is that I can also take the console object on the global object and override its properties, so the log, the warn, etc., in order to make it log into my own stuff. And that's the result. Now, the console is logging into com kdab log console, and my own log is going in com kdab log. Just like that. It's just those 4 lines of code. I'm publishing everything of that on kdab GitHub, so you can get an idea. And that's it. Thank you.